Everybody, welcome back to the Section 2.2 video. Let's go ahead and now turn our attention to solving some initial value problems using the separation method. So here's this example right here. Looks a bit familiar to an equation we've been working with before, but we have dy over dx equals negative x over y, and we have this initial condition y of 4 equals negative 3. So we want to solve this differential equation, and then we want to figure out what the constant is. So first thing we want to do is isolate my variables, get y to one side and get x to the other. So let's do that. We have dy over dx, just rewriting the equations to give us some more space, but I'm going to clear out this dx to both sides. And so what I have is dy equals negative x dx. Okay, and then, excuse me, I forgot the y. And then I'm going to move the y over to the other side. So I'm going to multiply y to both sides. And so now I have my variables cleanly separated. And then what's the goal? We want to integrate both sides. So what I'll have is 1 half y squared equals negative 1 half x squared plus c. Okay, but I want to solve for y. Yeah, I want to solve for y here. So what I'm going to do is clear out y to both sides. So I'm going to multiply both sides by 2. And so the 2's cancel out. So what I'm left with is y squared equals, if I distribute in this 2, it becomes negative x squared and then plus 2c. But 2c, that's just a constant, 2 times a constant. So we can just say it's just another constant. You could say c again. It's just another constant. Okay, so we have y squared equals negative x squared plus c. Remember, this is an initial value problem. So I'm going to bring this up here, and I want to use that initial condition. So I'm going to plug in 4 and 3 into this solution now. So this would be negative 3 squared equals negative 4 squared plus c. So it's 9 equals negative 16 plus c. Add 16 to both sides, and I get 25. Okay, so let's take that c, let's plug it in. So y squared equals negative x squared plus 25. Remember, I want to solve for y. So what I need to do here is square root both sides. And so what I would get is y equals plus or minus square root of negative x squared plus 25. And this is something we touched on before, that our interval of solution, we need to establish that because we have a square root here. We can't have any negative roots. It would be negative 5 to 5. So therefore, that's my final answer. Okay, let's go ahead and try out the next initial value problem. Example 2. So this one is a bit messy. Okay, so what we need to do is figure out how we want to move some pieces to the left or to the right. Okay, we have e to the 2y minus y times cosine x dy over dx equals e to the y sine of 2x. Uh, what I want to do is then move my y terms to the left side and move my x terms to the right side. So I'm going to divide by e to the y to this side. And I'm also going to also divide by cosine of x to both sides. That's because it would cancel out here and the cosine would cancel out on the left side. And so what I'm left with is essentially e to the 2y minus y over e to the y dy equals sine of 2x over cosine x. Okay, so still a bit messy. I can't integrate yet. Uh, what we will need to do now is start using some algebra to simplify this down. So what I'm going to do is uh, let's start taking the integral. Let's set up the integral so that we don't lose our way. But I want to start simplifying this down. So what I'll do here is separate out e to the 2y. I want to separate out this denominator or numerator with that ey denominator. And what I'm going to do for my right-hand side with my sine 2x, let's remember a trig identity that sine of 2x can be written as 2 sine x cosine x. Okay, so I could rewrite sine of 2x as 2 sine x times cosine x all over cosine x dx. Okay, so this works out great because the cosines cancel out here. And I can also cancel out on the left-hand side e to the y, and then that one of those copies of e to the 2y. Okay, so what I'm left with now is the integral of e to the y minus, and I'm going to bring up that e to the y up to the top. So it'd be y e to the negative y dy equals the integral of 2 sine x dx. Okay, so we have a couple integrals to solve. We have e to the y e to negative y, 2 sine x. So two of these look very easy to me. Just e to the y is easy. Uh, 2 sine x is easy. But with y e to the negative y, that's a little more complicated. For this, we are going to need integration by parts. Okay, so what I'm going to do is separate these two integrals. I'm going to separate these two integrals and I'm going to do integration by parts. So with integration by parts, recall, I'll write it up here. it's uv minus the integral of v du. And so for the integration by parts for this y e to the negative y, my u would be y, and my dv would be e to the negative y dy. Okay. In case you need some more reference, kind of followed by that lipid, log inverse trig polynomials, exponential, and just regular trig. So whichever pops up first on lipid is your u. So y is a polynomial. It pops up first on my lipid and in my integral. So it would be my u. And dv would be whatever the other function is. So e to the negative y dy. Just a bit of review, but let's get back to this integral. So it's got to take the derivative of u. So du equals just dy. And so that's a derivative of y. Now let's take the integral of v, the antiderivative. And that's sort of like a mental use of as well. But we'll kind of fast track that. It would just be negative e to negative y. Okay, so that's my setup for integration by parts. I'll label it IBP. And so let's bring it back up here. What I would have is the integral of e to the y dy minus my integration by parts, negative y e to the negative y minus the integral of negative e to the negative y dy. Got to be careful with all those negatives. Equals the integral of 2 sine x dx. Okay, so let's go ahead and distribute in this negative. We want to clean up all these negatives so we're not getting the incorrect answer. So integral e to the y dy plus y e to the negative y plus the integral of negative e to the negative y dy equals the integral of 2 sine x dx. Okay, so we're almost there. Uh, Now what we want to do is finish these integrals. So I like to integrate all at the same time. So I'll make a note like, you know, I prefer to integrate at the same time. All right. You could do it piece by piece if you want. You could have integrated earlier on the easier integrals, but I just like to do everything at the same time so I'm not missing anything. Um, so let's go ahead and integrate this. So this would be integral of e to the y. It's just going to be e to the y. I don't need to integrate this y e to the negative y. That comes with our by parts. And then the integral of uh, negative e to negative y, that would just be negative e to the negative y. Another one of those mental use ofs that we want to utilize quickly. And then this would be negative 2 cosine x plus c. And so let's clean this up a bit. Let's cancel out those negatives. E to the y plus y to the negative y plus e to the y, or excuse me, negative y equals negative 2 cosine x plus c. Okay, so that is our solution, but remember we have an initial condition right here. So we need to use the initial condition. We're going to plug this into our solution now. So this would be e of 0 plus 0 e to the negative 0 plus e to the negative 0 equals negative 2 cosine of 0 plus c. Uh, e to the 0 is 1. 0 plus e to the negative 0 is 1. Negative 2 cosine of 0 would just be negative 2. And so c equals 4. Okay, running out of room a bit. Uh, but let's go off to the side here. So, therefore, the solution would be e to the y plus y e to the negative y plus e to the negative y equals negative 2 cosine of x plus 4. Okay, we could possibly isolate x. We could add 4 and then, or subtract 4 and divide by 2 to both sides. And then you could inverse cosine both sides if you want. And so what you could get is, essentially x equals inverse cosine of e to the y plus y e to the negative y plus e to the negative y minus 4 all over negative 2. So either or of these are okay. Either or of these solutions are good solutions, just whichever you prefer. If you like solving explicitly, you can isolate that x, but if you are okay with the top equation, that's fine too. So a bit of a long question, just a lot of like identities and remembering integration by parts, but it's good to practice these skills again. But that's it for this video, and I'll see you guys in the next one. Okay, take care.